is a naturalist and an environmental activist dedicated to landscapes of the southwestern Oregon and northwestern California. He serves as executive director for the Applegate Siskiyou Alliance, conservation director for the Klamath Forest Alliance, and also volunteers with the Siskiyou Crest Coalition. So he's got a bunch of extra time on his hands. In this presentation, Luke will highlight the ecology of the subalpine fir in the Klamath Mountains with a special focus on the Siskiyou Crest. He will share recent findings from the headwaters of Yale Creek and Little Applegate River watershed, where a newly documented population of subalpine fir has been discovered. And so just give me a moment while we switch sides and bring Luke up.
What if you did not volunteer operations? Just for them.
What are you doing?
For next week. Yeah.
Well, I'm definitely.
Okay. So, hi everybody. My name is Luke Riediger. And I was going to talk tonight about subalpine fir, so Abies lasiocarpa on the Siskiyou Crest and in the Klamath Mountains. So subalpine fir, as the name might keep people into, is a tree of deep winter snowpacks and cool, moist habitat conditions. So in much of its range, it extends up to tree line, where it grows in dense forests up to 100 feet tall. And in more open habitats, it grows in subalpine meadows, parklands, and areas with persistent snowbanks and short growing seasons. So being intimately tied to these truly kind of subalpine habitats, the populations in the Siskiyou Crest or in the Klamath Mountains show up only at the highest elevations and in the most pronounced climate refugia. And mostly they're found on granitic substrates. I switch these. There? Okay, there we go. That work? What's going on here?
You could click on the photo.
No. Oh, okay. It's working now.
No, it's not.
Oh. Sorry, technical difficulties.
Hold on.
Different every time.
There you go. Just the arrows should
The arrows, okay.
It's gonna.
Okay, that works.
But what not switching?
Here, let
me just switch real quick.
Sorry, guys.
Maybe we have too many of them.
Let me see.
That's from the previous presentation.
Go. All right. So sorry about that, everyone. And here we go. All right. So we're just going to pick up where I left off here. So this is the second slide. So montane forests in the Klamath Siskiyou Mountains, like those in this photo, generally consist of mountain hemlock and a whole lot of different true fir species. So Abies like white fir, noble fir, red fir, and Shasta red fir. There's also a fair amount of western white pine and Jeffrey pine at these higher elevations on the serpentine sites. So the area within the Klamath Siskiyou Mountains is known for its diverse conifer forests, which reach a climax in the montane forest belt. So here you will find what late ecologist John Sawyer called enriched conifer stands with elevated levels of biodiversity and disjunct or endemic conifer populations. These stands can contain endemic species like brewer's spruce, as well as disjunct relics like Alaska yellow cedar, Pacific silver fir, foxtail pine, whitebark pine, Engelmann spruce, and of course, subalpine fir. So subalpine fir is common throughout the West. There are three distinct varieties. So there's Abies lasiocarpa variety biflora. This is the Rocky Mountains subalpine fir. It extends from the Yukon and British Columbia down the Rocky Mountains to north central New Mexico. There's also Abies lasiocarpa variety arizonica, or the corkbark fir, and it's found in the Sky Islands of western New Mexico and in Arizona. And it has this distinct corky bark. It's a little bit different than some of the other ones. And then there's also the coastal subalpine fir, which is what we have in our region, Abies lasiocarpa variety lasiocarpa, which extends from southeastern Alaska and down the Cascade Mountains to Crater Lake, with disjunct populations south down into the Mountain Lakes Wilderness area. And then there are some even more disjunct populations scattered around the Klamath Siskiyou Mountains along the Oregon-California border. This photo shows kind of more typical subalpine fir type of habitat. This is up near Mount Rainier in Washington. And then there's also a range map there showing you kind of where the distribution of subalpine fir is. So in the Klamath Mountains, there are 11 known populations of subalpine fir scattered throughout the region. That includes 3 populations on the Siskiyou Crest and 8 populations in the Klamath Mountains to the south. These populations in the south, in the Klamaths, can be found in the Marble Mountains Wilderness, in the Russian Wilderness, and into the Scott Mountains above Callahan, California, in the Trinity Alps Wilderness area. So this map shows its known distribution in the Klamath-Siskiyou Mountains, with the red dots corresponding to distinct populations known to exist in the area. It's thought that subalpine fir migrated into the area in the last glacial period and expanded during glacial contraction. During this time, previously glaciated lands were colonized by vegetation, including subalpine fir. So there's been some studies done on pollen records and sediment records, and they show that the colonization of subalpine fir began roughly 10,000 years ago. And it began to expand during the Little Ice Ages about 1,300 to 1,800 years ago. And there's also a study that was done in the Scott Mountains at Bluff Lake that found subalpine fir needles within those sediment cores that were between 4,400 and 2,100 years old. And since that time, the climate has warmed, obviously. The small glaciers have melted. The persistent snowbanks on the north slopes of the region are diminishing. And that's really just reduced the habitat niche available for subalpine fir. And it's made it essentially the rarest conifer in the Klamath Mountains and one of the rarest conifers in California, where it grows down south. So I'm going to look real quick at some of the populations in the Klamaths before we move on to the Siskiyou Crest. So in the Klamath Mountains in California, the populations, as I said earlier, there's populations in the Marble Mountains Wilderness area with a particularly robust population around Shelley Meadows, which is up on the North Fork Salmon River. There's also populations at Frying Pan Lake and Deep Lake in the Marble Mountains. And in the Russian Wilderness, there's a number of populations, one of which is near Little Duck Lake, in an area that people know as the Magic Mile, where there's these highly enriched conifer stands with as many as 19 conifer species in a square mile. In the Russians, there's also populations in a place called Horse Ridge Creek, excuse me, Sugar Lake at the headwaters of the Scott River. And there are some extensive populations on Russian Creek up at the headwaters of the Salmon River, and near Russian Lake in the Russian Wilderness area. And again, that southernmost population is in the Trinity Alps, above Fox Lake in the upper Scott River drainage. So within those 8 populations in the Klamaths, one of the things that stands out is that they're found predominantly on granitic bedrocks and in cool, moist microclimate conditions, generally on north and east facing slopes and generally above around 6,000 feet in elevation. So this screenshot here of a Google Earth image, I just picked this out because it shows kind of a cluster of populations in the Russian Wilderness area. And obviously you can tell that they're growing in that granitic bedrock. So again, these dots represent distinct populations, but they don't necessarily show the spatial extent of those populations. So for instance, there's a kind of an isolated dot there in the bottom of the drainage at Russian Creek. And that's actually a pretty extensive population. That whole upper drainage is populated by subalpine fir and also disjunct populations of Engelmann spruce. But the point is that nearly all the populations in our region are found on granitic substrates. And so there's just another way of looking at it. This geologic map shows granitic plutons in light blue. And you can see that subalpine fir populations, shown again as those red dots, correspond with a lot of the granitic outcrops in our area. I would note there's two populations there kind of in the center of the geologic map that are off of those light blue granitic substrates. And those are the Frying Pan Lake and Deep Lake populations, which actually grow on ultramafic soils. And then on the other side of there's a couple more photos there, aerial imagery, and it just again shows that granitic bedrock surrounding populations at Shelley Meadows and at the Fox Creek Lake area in the Trinity Alps. So I'm going to kind of switch gears here and talk a little bit more about a little more specifically about the subalpine fir on the Siskiyou Crest, where three local populations have been documented. Until fairly recently, it was thought that Mount Ashland was the only population in the Siskiyou Mountains. And this population has been known about for quite some time. It was documented as early as 1908, when George Sudworth stated in his book, Forest Trees of the Pacific Slope, that subalpine fir was present on the north slope of the Siskiyous where it is rare. So the small population on Mount Ashland grows just north of the mountain summit at about 7,400 feet in elevation. It grows in gravelly, decomposed granitic soils. The entire population contains maybe 15 or 20 upright trees and then a big dense mat of kind of Krumholtz vegetation. It's kind of just a mat of blue-green foliage. In 2001, the Forest Service estimated that the entire population at Mount Ashland was about 1/10 of an acre, and it consisted of an unknown number of individuals. It's thought that the population up there at Mount Ashland was larger before the creation of the Mount Ashland Ski Resort, which appears to have removed portions of subalpine fir population for ski run and ski lift development. And there's additional impacts up there on top of the mountain that include the communications infrastructure and the Doppler radar dome. And the current populations lie pretty precariously close to these developments, and they continue to be impacted by them. So unfortunately, kind of due to poor oversight by the Forest Service and mismanagement by the ski resort, this past fall, the Mount Ashland Ski Association cut down the majority of the beautiful subalpine fir stand. They were doing what they believed was routine ski run maintenance, but they cut down most of the Krumholtz mat that was, adjacent to or within the population there. So you can see in this photograph, the mat has been cut down, but there is a few upright trees that still remain up there. Ironically, the environmental documents that pertain to the authorization of the ski resort's special use permit and the Mount Ashland ski expansion claim that the operations will create no effect, and clearly identified those populations as something to be retained and protected. Yet that's not exactly what happened when the ski resort cleared these runs up at the top of the mountain and near their upper chairlift this past fall. So this photo was taken in 2018, and it shows the subalpine fir population before it was cut. And you can see how it's kind of just a big, dense mat of low-statured trees. Again, that's why the Forest Service had a hard time figuring out how many trees there actually are there, is because it's just a thicket of low-growing subalpine fir there. And then this is that same spot after the Krumholtz mat was cut. So it gives you an idea of, a pretty good chunk of that population was impacted really recently by ski run maintenance. And I just wanted to note that we don't really know how this population is going to respond to this. Clearly, the impact is in no way positive. I worry that it could even lead to sort of an extinction level event up there, but it also could rebound. We don't really know. What we do know is that this was an already very small population, that this population has been contracting for likely thousands of years, and it was just made artificially smaller. So, you know, the population up there at Mount Ashland is really the only population around that's been impacted like this by more anthropogenic impacts. And it's just kind of uncertain and undetermined, you know, how this is going to respond and what this is going to look like down the road. But clearly it added additional stress to an already marginal and kind of population that's sort of on the edge. The second population of subalpine fir is up at Tanner Peak or near Tanner Peak. It was discovered and documented by Frank Callahan in 1997 in a small headwater basin east of the Tanner Lakes in the Red Buttes Wilderness area. So this population consists of about 10 to 15 small trees growing amongst an alder thicket about 6,000 feet in elevation on a northeast facing slope. It's growing on diorite soils, which is related to the granitics. It's in a small rock-bound wetland in an area that supports some pretty deep snowpack because you get these maritime storms and kind of moisture-laden air that drifts in from the coast and from the more coastal influenced areas and dumps quite a bit of snow as it comes up over the 6,000 to 7,000 foot peaks of the Grayback Range. And I think that that's, you know, one of the things that's contributing to this population is that it's a pretty moist, cool, moist site that gets a lot of wintertime snow. And so that the bigger picture there on the, I guess that would be the left, shows a couple of the Krumholtz trees. One of the things that's interesting about this stand, and we'll talk a little bit more about this later, but subalpine, this stand burned, or the areas adjacent burned, I guess, during the 2020 Slater fire. Subalpine fir being a high elevation species and a subalpine species, it doesn't have a lot of natural resistance to fire. And instead it's adapted to avoiding fire by growing in fire refugia, by, you know, maintaining itself in cool, moist habitats and areas with short growing seasons. So in the Klamath Siskiyou Mountains, these stands, the subalpine fir in general, relies on pronounced fire and climate refugia, and it grows in areas that are often either too rocky or too moist to burn for most of the fire season. And as I said, this population, you know, it burned around it in that 2020 Slater fire. That was a really, really hot wind-driven fire. It was really ripping through a lot of vegetation and a lot of really pretty fire-resilient vegetation on that southern face. It was experiencing like 60-mile-an-hour winds. But as the fire pushed up over the ridge and onto the north slope of the crest, that slope reversal transformed that fire from a wind-driven slope burning uphill to a backing fire. And it just burned right around that population at pretty low severity in the montane forest surrounding it. And so it just maintained its persistent fire refugia and demonstrated how those kind of things can work over long periods of time and in you know, distinct fire events.
Is that picture taken after the Slater fire?
This is after the Slater fire. So you can see there's a little bit of burn effect back there in the montane forests, and it just burned at low severity in the montane forests around the stand, but it didn't actually burn into the subalpine fir population. And this is just another photo. It shows you kind of the Krumholtz structure of the Tanner Peak subalpine fir population. It does have that kind of low mat vegetation, and it also has some more upright trees. Most of them are about maybe 8 to 10 feet tall. And they're growing in these alder thickets and oftentimes at the edge of the thicket in really rocky areas with like virtually no conifer competition. And it's growing in a lot of times with little thickets of huckleberry and stuff. And this population it's pretty stable. It seems to be doing pretty good. And it's thankfully protected in the Red Buttes Wilderness area. So, you know, other than climate change and fire, it's likely that this will persist until conditions change. And, you know, it is a diminishing population throughout the crest, but this population in particular seems fairly stable.
Your impression, how old is it?
You know, it's really hard to say because my take on this is that the trees are very slow growing. They're in pretty marginal habitats. You know, I haven't like cored any trees or anything like that. I know that Michael Kaufman looked at that stand and he thought it was a younger stand, that it came in recently. I kind of feel like it's probably a relic hanging on from a larger population historically, but I don't think anyone really quite knows. It's how old the individual stand is, I don't know, but my guess is that that population has been contracting for quite some time.
Amount of bigger trees.
I'd say they're a little smaller than the ones that we saw, like maybe 6, 8 inches, something like that. So anyway, that's the Tanner Peak population, the second population that was discovered in the Siskiyous. And the third population of subalpine fir was found recently in the summer of 2024. Applegate Siskiyou Alliance that I work for led what we called our Siskiyou Crest conifer field trip series. And during that series, we visited all 26 species of conifers found in the Siskiyou Mountain or the Siskiyou Crest region. We did that in 8 field trips, and one of those field trips was up to Dutchman's Peak. So while leading this particular trip, we visited a beautiful population of common juniper, and we had to kind of bushwhack down into this basin to go see that common juniper, that mat-forming juniper. And while we were there, I was kind of walking up the slope and I noticed this low mat-forming conifer with pretty distinctive blue-green foliage. I looked a little closer and it was like, I'd just been up at Mount Ashland a few weeks earlier looking at the subalpine fir up there. And, you know, I looked at the needles, the way they're arranged around the stem, kind of in a star-shaped pattern all the way around the stem there. And I was wondering, as I walked up the mountain, if what we had just found was the third population of subalpine fir on the Siskiyou Crest. So I know folks on Zoom aren't going to see me doing this, but the population is basically right here.
Did you find any cones?
No cones that I've seen. So this population is located at the headwaters of Yale Creek in the Little Applegate River watershed at approximately 7,000 feet in elevation. It grows in a small, moist cirque basin northeast of Dutchman Peak. My estimate, I didn't actually measure it when it was there. Maybe it's the mat is maybe 30 feet around or something like that. It's a pretty dense mat of mostly crumb-halt stems. There are some upright stems that mostly have died off. But in general, the population here, I don't know if it's a tree or numerous trees, it's hard to tell. They're generally growing, that foliage is generally from maybe 3 to 6 feet high. The dense mat portion of this appears pretty vigorous, but like I said, most of the upright stems have died off and are now snags. One of the things I found interesting when you looked at this population is, again, it was really hard to tell how many trees are actually in there. It's sort of, most of the population is kind of sprawling across the ground. I looked in there was about 8-inch diameter stems, but they're just growing literally prostrate across the ground and then sending up shoots from there. And so, you know, it's hard to know whether it's just a struggling population or whether it's the deep snow loads or just being propped down by the elements. But it's most of this population is just a low mat of conifer foliage. And I did look around in there and find old stems. I found broken stems and recently killed stems. And so it's, you know, it's hard to know, but it does seem like this population also is probably in the process of contracting and is basically now just this one little clump up at Dutchman Peak, or at least that's all we know of. So for the Siskiyou Mountains, the area where this population grows is clearly quite a subalpine habitat. It's one of the few hanging valleys that I know of in the eastern or in the Siskiyou Mountains, really, that's over 7,000 feet in elevation. So the population again, I'm going to is right there, and it's growing within a kind of a moist meadow basin. And there's a lot of high elevation kind of clearings and pretty deep snow loads in the winter months. oftentimes there's a big deep snowbank hanging around late in the season on the saddle right up above. So it's a cool, moist habitat. Most of the forest surrounding it is dominated by mountain hemlock. There's red fir in there, and some white fir. But basically within that matrix of montane conifer forest is this one population of subalpine, or this one little stand of subalpine fir. So on August 3rd, 2025, we went back to the population with multiple botanists. So Julie Kierstead, Wayne Raleigh, Barb Mumbolo, Cesar Garcia, and Susie Savoy and myself all went up there. And everyone agreed that this is the third population of subalpine fir on the Siskiyou Crest. And Julie Kierstead has been preparing and sending off voucher specimens to both OSU and Cal Poly Humboldt. Later on, after we went up on the mountain, Wayne and Cesar Garcia inspected the foliage under a dissecting scope. And I stole Cesar's picture here, so thank you. But what it showed was when they inspected a little closer with these characteristic resin ducts, kind of closer to the mid vein of the needle rather than out towards the epidermal layer. Cesar took this photo under a dissecting scope, and it indicated a positive identification of subalpine fir. The drawing adjacent to it shows is from the flora of the Pacific Northwest, and it shows that that same resin duct there in the middle, prominently towards the middle of the needle there. So outside of the threats of development or land use like those at Mount Ashland, what are the threats to this species in our area? Well, it appears that one of the biggest threats to this species is climate change. It's already, the species is already and will likely continue to be affected by big shifts in precipitation and snow that are brought about by climate change. We already have a relatively narrow high elevation snow zone up there. And one of the things I wanted to note was that in 1916, which is the author J. Frank Hanley claimed Mount Ashland could hold up to 100 feet of wind-piled snow. That might be a bit of an exaggeration, but it gives you an idea of the alpine environment on the mountain in 1916. It certainly holds nowhere near 100 feet of snow these days. This painting that I put here is from a book called A Day in the Siskiyous. Again, it was published in 1916, and the caption for this painting was Mount Ashland's 100-foot depth of wind-piled snow. So one of the problems that we're going to be seeing here is that in many locations, the species literally has nowhere higher to migrate as the climate warms, because it already exists within these climate and fire refugias at essentially the highest elevations on the Siskiyou Crest. So it survives in microclimates that mimic the Cascade Mountains, and to some extent the Rocky Mountains to the east with deep snow loads, where most of the population grows. But this small population on the Siskiyou Crest is already essentially inhabiting the highest elevations and some of the most alpine environments in the region. So for example, you can see on these maps, again, the red dot shows where the populations exist, and you can just see they don't really have anywhere to go as the climate warms. They're already in the coolest, most moist, high elevation habitats that they can find. So the other thing that's going to be interesting going forward is that climate change is, it's exposing these like niche habitats in the Klamath Mountains to warmer, drier conditions, lighter snow loads, longer growing seasons. All those things could just favor other species that could outcompete the subalpine fir. They also tend to bring more active, frequent, and severe fires than we maybe have historically seen in these fire refugia. So the map that's on this slide shows the last 20 years of fire history in the Klamath Mountains. So all those different polygons on there and the different color represent fires in different decades or in different years. But in the last 20 years, you can see that, again, looking at those red dots on the map that depict subalpine fir populations, a fair number of these populations have been within the fire footprint of numerous fires in recent years. So I'm just going to talk real quick about what that looks like on the landscape. So being a subalpine species, subalpine fir is sensitive to fire. It tends to support a low frequency fire regime, and is characterized by long fire-free periods. It also is characterized by mixed severity fire effects, and oftentimes has a significant high severity fire component because these trees are just not very well adapted to resisting fire. And the other thing that I wonder about is that, given the long fire return intervals required by these species and the relatively frequent fire in the Klamath Siskiyou Mountains, like I've been saying, this species is already, existing in these fire refugia and these little niche habitats where fires tend not to burn, tend to burn very infrequently, or tend to burn very lightly. But again, like I said, they don't have much adaptation. So even a light fire can kill these trees off. So, what we're seeing out there on the landscape is that the fires are, in some cases, burning into subalpine fir populations. And then in other cases, they're burning around subalpine fir populations. So those populations that the fires have burned into, at this point, we're just hoping they will effectively regenerate. And we don't really know until folks go out there and really take a little bit deeper look at what's happening in recent, because most of these fires are pretty recent. So I was going to kind of show people what that looks like. So here are a few examples of recent fire effects through, looking at these aerial images. So this is the Fox Creek Lake Basin in the Trinity Alps. This is the southernmost population. My understanding, and I haven't actually been to this stand, but my understanding is the subalpine fir grows in the headwaters above the lake basins there and adjacent to some of the meadows. And then you can see the other photo there shows the effects of the 2021 River Complex fire. So the river complex was a pretty big burn. It burned in the Salmon River watershed, the Upper Scott, and into the Upper Trinity. But you can see how there is some remaining montane forest up there in the headwalls and around those meadow basins. So again, I haven't visited this site since it burned or anything, but we're hoping that some of that population is surviving there in the Fox Creek Lake area. This is the Russian Creek population. And again, this you can see in 2013, the unburned condition. And then you can see adjacent to that, the effects of the 2014 Whites fire. And this fire burned, it was actually, there were some portions of this fire that got pretty hot and burned large swaths of forest. But as it approached these higher elevation areas, you can see that it left that whole upper drainage unburned. And that's where you have a big population of subalpine fir and Engelmann spruce. And so pretty good fire effects there and pretty good survival after the 2014 Whites fire. And I've hiked through there since then, and there's certainly a lot of trees still remaining. But this past July, the 2025 Big Cliff Fire burned back through a portion of that population in Russian Creek and up on the Blake's Fork. And reportedly, it burned at really low severity. It was a really a patchy mosaic burn, left a lot of unburned habitats. But what you're seeing in this slide is in orange, you have that 2014 Whites fire footprint. You can also see a 2001 Whites fire in yellow. And in that more bold yellow, you can see the 2025 Big Cliff Fire. And you can see that once again, that whole upper drainage just didn't burn. So despite having numerous downstream fires, you've still got that fire refugia in the upper basin where the population is doing well. And then reportedly, in that lower population, even after that Big Cliff Fire, the severity was really minimal, and there should be some unburned islands in there where the trees remain. This shows Shelley Meadows, which is also a large population up on the North Fork. Most of the population is up in this upper basin here, adjacent to the meadows and the lake. So this is actually a pretty extensive population. Most of the population was between the meadow basin and the lake basin up above. But you can see again that 2013 unburned condition. And then in 2017, the Wallow Fire burned through that area. But a pretty good chunk of that population, I hiked that area right after the Wallow Fire, and a good chunk of that population remained viable after the fire. And basically persisted in unburned habitats within the fire footprint. But then, in 2024, Shelley fire burned through that same area. So you can see the effects of that wallow fire in 2017, and then you can see the reburn effects in the 2024 Shelley fire. And you can see once again that upper drainage basin, made it through pretty well. And there should be, I haven't been there since the 2024 fire, but there should still be a lot of subalpine fir remaining in that area. And then I was just going to show this one slide. This is the Tanner Peak population again. We talked about that a little earlier with the Slater fire that burned through there. But you can see how in 2015, in the unburned photo there, there's a lot of green forest. And you can see how in, following that 2020 Slater fire, there's still quite a bit of green trees in there. The population, again, folks on Zoom might not see this, but the population is kind of right in this area here. And so you can see that a lot of that made it through, and that population is still persisting and doing pretty well up there in that fire refugia. So the other obvious threat to subalpine fir is just small population size. That can lead to genetic traps. It can, make the population vulnerable to natural disturbances. Basically, what we're looking at in the Siskiyou Crest region is 3 separate populations and probably less than an acre of occupied habitat. So basically, there's not much room for error. These fire refuges need to work, and they're going to be stressed by climate and other impacts that could lead to problems, could lead to regional extinction. Populations could make it through. We just don't know. So we're working to document the stands, protect habitats, and support the populations the best as we can at a localized level. And one of the ways we've been doing that is trying to document these populations. So recently, citizen scientists, naturalists, trained botanists, and nonprofits worked to document this new population, albeit a very small population at the headwaters of Yale Creek. It's presumed, as I said, that subalpine fir colonized these areas during a much colder period. And so this population's really been contracting, and we're left with just these really, really small population sizes and just a few scattered populations around the region. And I believe this may be one of our most threatened conifer species on the Siskiyou Crest because of all those different factors. So one thing I wanted to note was that I'm continuing to look for subalpine fir. There could be more populations out there. And when I'm doing that, I'm going to pay a special attention to those granitic areas on the crest. So I've got those kind of circled, some of the populations and some of the areas that I think populations might exist. So I'm going to be looking more around Mount Ashland, Wagner Butte, McDonald Peak, Siskiyou Peak area where you have granitic intrusions. You can see that population over here. This is Dutchman, and it's in a small granitic intrusion. And there could be more trees up there. We looked around pretty good, but one tree could be hiding. Other areas that I think are worth looking is around Grayback Mountain, where you have pretty high elevation granitics. And then also out in the Siskiyou Wilderness area, where perhaps populations could exist around Preston Peak, near Devers Punch Bowl, or in some of those high elevation granitics in the Siskiyou Wilderness area. The one thing to think about is there are 2 populations in those ultramafics. And if you start looking at ultramafics, then you got a lot of ground to cover. So we don't really know, but I think it's worth looking, and I think it's worth exploring and seeing if we can find more populations out there. So I just wanted to kind of end it by encouraging folks to get out and explore the Siskiyou Crest and the Klamath Mountains. There's still much to be explored, and there's still much out there to be found. And additionally, since this is what I do, I'd like to encourage people to help us match the world-class biodiversity of the Siskiyou Crest with world-class habitat protections. So if people want to plug in, I encourage you to join local conservation groups that are working to protect this landscape for future generations. And we're working to protect the biodiversity that we know is out there, and we're working to protect the biodiversity that we have yet to discover. So we have a petition on our website. We encourage people to sign on and support. You can go on to the SiskiyouCrestCoalition.org website and sign on in support of that. And we just think the Siskiyou Crest is a beautiful place and has a lot to offer. Some of the most incredible botany around. And as we found just here in 2024, there are new things to be discovered. So anyway, that is the story of the recent discovery of a new population of subalpine fir on the Siskiyou Crest, and that's what I've got tonight for presentation.
We have some questions.
Okay.
Thank you very much. And I'm gonna pull up the chat for you.
He's got one here, if you want to start. You'll have to repeat it for the Zoomers.
Okay.
Did you see any reproduction, like I've seen it in, in the Rockies, reproducing dove under Pines contorta? And I'm wondering if around here, if it's does it require bare mineral soil?
So the question is if people are seeing reproduction, and whether or not it needs bare mineral soil. Honestly, I haven't seen a whole lot of reproduction. I have seen some smaller trees. But again, it's kind of hard to know how old those trees are, because the older trees are only 6 or 8 feet tall. So, you know, what looks like a little sapling could be older than it appears. There are some smaller trees around, but mostly what we're seeing is, you know, mature trees that are 6, 8, even like 3 feet tall, you know. I don't know in the fire areas. You know, when I went into the Wallow fire area right after it burned. So obviously there wasn't reproduction that fall after the fire. I did the same thing in the, you know, I've been to a couple populations and it's all been directly after the fire burned. So I was able to see what those fire effects were immediately after the fire. There could be some more mortality that occurs delayed after the fact. But I'm not sure how they're reproducing, you know, after fires. Generally, the way the populations work is they burn down, or patches burn down, and then they regenerate. But these are really marginal habitats. It's hard to know if they're going to operate like they do up north, where they have a lot more moisture and are in better growing conditions.
You could mention tip layering.
Yeah, that is one thing that's interesting about subalpine fir is it's a conifer that's known to tip layer and to root. And so a lot of these populations that are kind of sprawling around on the ground, one of the things that makes it really hard to know how many trees are actually in a population is that those trees are rooting in and then, you know, growing from those rooted nodes. So they do reproduce vegetatively, and they are doing that. So there's a question from Christy about how was the low-growing Krumholtz mat an issue for the ski resort that they cut it down? How did the Forest Service lose or forget about the disjunct populations while working consulting with the ski resort? Great example of refugia on Tanner Peak. Thanks, Lou. Congrats for discovering the population on Dutchman. So I don't really know how to answer that question. You know, obviously, there was plenty of documentation of the populations at Mount Ashland. Folks should have known they were there. Folks kind of did know they were there. Somehow that communication didn't get passed on. So I think that it just kind of shows that, you know, that the Mount Ashland Ski Resort and the Forest Service needs to put a little more emphasis in maintaining and protecting the unique botanical diversity that Mount Ashland does support. And I don't know if Wayne has something to say about it, but I know that Wayne's been working with the mountain to try and work with them to better protect some of those rare populations up there. Do you have anything to add, Wayne?
Basically, well, except that actually it really wasn't well known. Only a subset of people were really even aware of it in the Forest Service and with the ski area. And with the ski area, the few people that knew about it moved on, retired. You know, that's what.
Yeah, I think a lot of the problem really is turnover in the agencies.
I actually volunteered to be on one of their committees at the ski area to kind of help them deal with, it's what they call their environmental committee. And they're doing all kinds of environmental stuff, but, I'd say at least once a year, we'll probably do a little botanical review. I don't know how long I'll fill that role, but, you know, I'm motivated to do it now. We'll see how many years I actually can.
Yeah. So is there another question here?
I've got a question.
Wayne's got a question. What's the question, Wayne?
So when I go to a lot of places in the Oregon Cascades, or even farther north, Subalpine fir is growing like a normal conflict without layering, you know, without the compost condition. Do you have any idea what triggers that promotes condition? Do you think it's just wind and snow load and adverse conditions? I mean, a lot of times you can go and see lots of Subalpine fir in there. They might look a little bushy when they're young at the base, but not the way these populations look here.
So the question was about the Krumholtz form and kind of what's creating that condition. And, you know, the only thing I could say is that it's environmental conditions, but, you know, they are marginal habitats. You know, up north, you get more snow load, you get more precipitation. It's more of an ideal habitat. So the only thing I can think of really is just that the little bit more harsh conditions down here, the little bit more marginal sites have stunted growth and kind of encouraged that low growing Krumholtz form and encouraged that vegetative reproduction over cone, you know, seed reproduction. I mean, I can't say for certain because, you know, I go up to the Mount Ashland population off and on. I've been to the Tanner Lake population a number of times. And just as I've been exploring that Dutchman Peak population the last year, I've never seen a cone on any of the populations in the Siskiyou Crest. I have seen cone production down in the Klamaths in some of the more bigger populations. But again, I'm not sure how reproduction's playing out. I know they're setting seed, but I don't know what kind of germination you're getting or what kind of reproduction you're getting in those stands.
Well, they're thinking like people, you know, you grow up when you're young and you grow out.
So there was a question about white bark pine on the Siskiyou Crest. There is white bark pine on the Siskiyou Crest, but only a very, very small population at Mount Ashland. There was 3 or 4 trees historically that were known, and now it's down to about 1. So it's kind of up near the bowl at Mount Ashland, and that's another thing that we really want to make sure that folks at the ski resort are paying attention to. That was more on their radar. It's an endangered species, so I think it's required to be on their radar. But for whatever reason, the subalpine fir, although in the environmental documents that approved their use of the mountain, or at least more recently, it was known, but it just wasn't very well communicated that it was there. And so the mistake was made to cut it down. But I do think that that's something we really need to focus on, is making sure that one remaining white bark pine on Mount Ashland isn't impacted, through ski resort maintenance and things like that. The population is pretty much right, almost in a run. I mean, I think that's what led them to cutting it. It's right at the top of the mountain, kind of where runs all come together. So for their perspective, it was probably something they felt they needed to deal with. From a botanical perspective, it's obviously, unfortunate.
Can't even see it. It's under a big point.
Yeah, it's buried in snow most of the year. So there's a comment maybe, or a question here. It says, in the Greenhorn Mountains of Northeast Oregon, subalpine fir compete with white bark pine, and the fir is being cut to favor the pine. What do you think of that kind of conservation? I don't really know the dynamics or the situation up in the Greenhorn Mountains. Obviously, white bark pine is pretty imperiled. So I can see trying to emphasize the conservation of white bark pine, but I can't really speak to the ecological conditions up there in the Greenhorn Mountains. But you know, white bark pine is pretty special. So, is that it?
It is.
I think those are all the questions. Does anybody else have one?
She said, thank you, Wayne.
What she did.
Yeah, thank you, Wayne,
You're welcome.
Welcome, Christie.
So is there any other question?
We have.
The photo, the ducks. Oh.
So is there any other questions from folks out here?
Great.
Right on.
Compliments.
Cool. Well, thanks for having me, everybody.
Thanks.